Hello all, let's start section 5.4. 5.4 is sum and difference identities for sine and tangent. I will do again a proof for sum of sine. Then we do a quick proof for tangent. But again, I'm telling you, you are not required to learn the proofs. Only try to learn the identities and how to use them. To prove sine of a plus b, correct, I will use the co-function method. From co-function, I know that the sine of 90 minus theta equals sine of theta, sorry, let me correct this. I forgot to put the equal sign here. Sine of theta equals cosine of 90 minus theta. I'll use this, and also I'll replace theta with what? A plus b. Correct? Let's do that. If we do that, we can write sine of, instead of a plus b, I'll replace it with theta. Correct? You can replace it with theta. You're replacing your theta with what? With a plus b. Then you can write sine of a plus b equals, here you have cosine, keep your cosine, correct? Keep your 90, I have to open here a bracket, 90, minus, replace theta with a plus b. Now, we already know what is cosine of a minus b, correct? Then I'll use that trick from 5.3 and I'll work on it, correct? It's equal cosine of 90, correct? Cosine of a plus b, or let's go a different way, make it more easier for you. From here, let's work a little bit on the inside. If I work a little bit on the inside, it will be cosine of 90 minus a minus b. If I distribute the negative first, correct? It gives me cosine of minus a minus b. And easily I can group them based on mathematics, correct? You can group them like this. Then you can write this one equals to cosine of 90 minus a, correct? Cosine of b plus sine of 90 minus a correct? Sine of b. And if you simplify, use again the co-functions method, cosine of 90 minus a equals to sine of a, right? Based on the co-functions method. Cosine of b stays as a cosine of b. And sine of 90 minus a gives you cosine of a, correct? And keep sine of b. Here you go. On this side, I have sine of a plus b. Again, you don't need that proof. You need only this to memorize. Same way, you can go for sine of a minus b. You can do the same proof. I'm not going to do the proof for you. I'll just write it down for you. Sine of a minus b equals sine of a cosine of b, sine a cosine b, correct? Minus cosine a sine b. They are again the same. The only thing that you see is the sign. for the plus, this time you have, when you have here plus sign, you have also here plus sign. When you have here negative, here you have also negative. Correct? Same way, if you divide these two, it gives you, of course, tangent of a plus b and tangent of a minus b. Again, I'll skip the proof, then I'll write the formula for you. Tangent of a plus b equals tan a, tangent of a, plus tangent of b over 1 minus tangent of a, tangent of b. Same way, tangent of a minus b equals tangent of a minus tangent of b over 1 plus tan a tan b. Tangent of a, tangent of b. Another two identities. Here in this section, you're dealing with 4 identities. Example. Find the exact value. Find the exact value. Sine of 75 degree. Sine of 75 degree. Again, I know 75 degree is not in unit circle. I'm trying to rewrite as a sum or difference of two angles, well-known angles, that I have it in my unit circle. You see, if I add 45 degree with 30 degree, it gives me 75 degree. And I know this, all the trig functions of this, and I know all the trig functions of this. Correct? Then I'll rewrite sine of 75 degree can be rewrite as a sine of 45 degree plus 30 degree, which is sine of a plus b, right? I'm copying now sine of a plus what? B, correct? And sine of a plus b equals sine of a, which is sine of 45, correct? 45 degree, cosine of b, cosine of 30 degree, plus sine of cosine of a, which is cosine of 45 degree, sine of 30 degree. Now plug in the values. Sine of 45 radical 2 over 2. Cosine of 30 is radical 3 over 2. Plus cosine of 45 radical 2 over 2. Sine of 30 1/2. Simplify. Radical 6 over 4 plus radical 2 over 2 over 4. Correct? Example number 2. Same instruction. Find the exact value. Tangent of 7 pi over 12. 7 pi over what? 12. 7 pi over 12 is not in unit circle. Then I'll try to rewrite as a sum or difference of two well-known angles. Break 7 pi as a 3 pi and 4 pi, right? You can break 7 pi as a 4 pi over 12 plus 3 pi over 12. And if you simplify the right side, 4 pi over 12 means pi over 3. Because you can simplify by 4. 3 pi over 12 means 4 pi, pi over 4. Then I can rewrite tan of 7 pi over 12 actually equals to the tangent of pi over 3 plus pi over 4. Now it's in the form of tangent of a plus b, right? And we already know the formula, which is equal to tangent of pi over 3 plus tangent of pi over 4, tangent b, which is pi over 4, all over 1 minus tangent of a, which is pi over 3, times pi over 4. Correct? Replace the values from unit circle. Tangent of pi over 3 is radical 3. Correct? Plus tangent of pi over 4 is 1. Because it's sine over cosine, it gives you 1. Correct? Over 1 minus pi over 3, the tangent, here you have tan and here you have tangent. Tangent of pi over 3 again is radical 3. Correct? Tangent of pi over 4 is 1. It means you will end up with radical 3 plus 1 over 1 minus radical 3. Correct? You see your denominator has a radical in it. You have to rationalize. Then you can write radical 3 plus 1 times the conjugate of it, which is radical 3 minus 1 all over 1 minus radical 3. We have to rationalize the denominator. 1 minus, not numerator. I'll bring a little bit change here. What is the conjugate of your denominator? Your conjugate of denominator is 1 plus radical 3, correct? I will multiply here 1 plus radical 3 and I will multiply here 1 plus radical 3. Your denominator becomes 1 minus 3. Your numerator becomes radical 3 times 1 gives you radical 3 if you distribute. Correct? Plus radical 3 times radical 3 gives you radical 9, which is 3. Correct? 1 times 1 gives you 1. And 1 times radical 3 gives you radical 3. Let's simplify. Radical 3 plus radical 3 gives you 2 radical 3. Here, the square root of 9 is 3. 3 plus 1 gives you 4. All over 1 minus 3 gives you negative 2. You can factor out 2. It will be 2 times 2 plus radical 3, if I put in a nice order, over negative 2. These two cancels out. It means you end up with negative 2 negative radical 3 if you distribute your negative. Correct? Example number 2. In example number 2, we are looking after, they gives us like, let's say which one? Sine of 40. Sine of 40 degree. Cosine of 160 minus cosine of 40 sine of 160 degree. If you look carefully to this side is actually sine of A cosine B minus cosine A sine B. It's the same way of written, correct? We know what is on the left side of this. On the left side, we have sine of A minus B, correct? Then I can rewrite this as a sine of A, which is 40, minus 160, correct? Which gives me sine of negative 120. And based on the even functions, I know sine of negative 120 equals the negative sine of 120. Correct? Even and odd functions based on that. 120 is in our unit circle. And the sine of 120 is radical 3 over what? Over 2. Final answer. Correct? There are a lot of examples that you can go to your book and see. All of them are good examples. I think this was all about section 5.4. I'll stop the lecture here and see you all in section 5.5, which we will cover the double angle identities. I'll do again a proof there for you. And from there on, we will move towards the half angle identities. We will do some proof there, and we are almost done with our chapter 5, correct? We just do the half of angle and double angle formulas, and we are done with chapter 5. 2 more sections, and we are done with our chapter